Bismillahirrahmanirrahim. My name is Muhammad Arham and I am from BS Chemistry Department. Today my presentation topic is main reactions. First of all, I discuss with presentation layout. In my presentation, I tell you three reactions. First one is Wurtz reaction, Fitting reaction, and the third one is Wurtz and Fitting reactions. Um, I discuss its discovery. Who is the scientist who discovered these reactions? What is the definition of these reactions? What is the type of reaction, example, mechanism, and last one is application. First of all, I tell you about what's fitting reaction. In what's fitting reaction, I tell you about its discovery. Sir Charles L. Wurtz is a scientist who discovered this reaction. Now we move its definition. It's a coupling reaction wherein sodium metal is reacted with two alkyl halides in the presence of dry ether to form higher alkanes. Its reaction type is coupling reaction. And you know what is coupling reaction? A coupling reaction is a reaction in which two hydrocarbons are combined with the aid of metal to form hierarchies. So this is the definition of coupling reaction. And the dry ether is the ether. When we remove all the water from the ether is obtained is called dry ether. So this reaction take place in the presence of dry ether. Now I tell you about its example. Here is an alkyl halide in the presence of sodium and is also in the presence of dry ether. They form a sodium halide and higher alkane. So in the definition we discussed, we taken two alkyl halide. So in that example, I also taken two alkyl halides in the presence of sodium. They form high alkane and sodium chloride salt. Uh, In the definition, we discussed that we form a higher alkane when two alkyl halides react. So these are the ethyl chloride. Ethyl means the alkane which contain two carbon atoms. So when we get a product, we take a butane which contain a four carbon atom. So by this way, we form a four carbon atom higher alkane by using an ethyl chloride which contain a two carbon atom. So this example clarified the definition of Wurtz reaction. Now I move towards its mechanism. Its mechanism consists of radical formation. Here is an alkyl and this one is an halide. The homolytic splitting takes place. What is homolytic splitting? Homolytic splitting is a splitting in which one electron transfer to the atom. For example, this line show us two electrons. So due to homolytic splitting, one electron moves to halide and the one electron moves to aryl alkyl group. So here I formed a product R dot X dot show the radical sign. So when they react with sodium, the one sodium gains a halide to form sodium halide, and the sodium contains a alkyl group. So by this way we get this product. So when these react with again alkyl halide, so halide have a high electronegativity as compared to carbon. That's why they contain a negative charge, and this alkyl contain a positive charge. By this way, the negative alkyl and the positive alkyl combine to form a higher alkane, and the sodium combined with halide to form sodium halide. By this way, we can form higher alkane and two sodium halide. In example, uh, we studied that we produce two NaCl. It's been two sodium halide. So in a mechanism, we also produce two sodium halide. By this way, we this reaction take place. Now we move its application. It is very useful and very helpful for the formation of symmetrical alkane. Symmetrical alkanes means the alkane, the even number of alkanes, the alkanes which contain even number of carbon atoms. Now we move its limitation. Methane cannot be synthesized the Wurtz reaction because this reaction needs at least two carbon atoms. Methane contains only one carbon atom. That's why this reaction cannot be take place with the help of methane. So it is failed when we use tertiary alkyl halide. Okay, now we move towards Wurtz Fittig reaction. Wurtz Fittig reaction is also the type of Wurtz reaction, and these reactions are discovered by two scientists, Charles Adolph Wurtz and Wilhelm Rudolf Fittig. Now I move its definition. It is a chemical reaction of aryl halide with alkyl halide and sodium metal in the presence of dry ether to give substituted aromatic compound, and its reaction type is coupling reaction and substitutional reaction. Coupling reaction is a reaction in which the fragments of hydrocarbons combine with the aid of or with the help of matter, and the substitutional reaction in this the one substitute replace the other substitute is called substitutional reaction. In its definition, and we take an aryl halide and alkyl halide. So, in example, this one is an aryl halide and this one is an alkyl halide in the presence of sodium matter. So, when these combine, uh, then then this product is formed. So, these are attack on these are replace the halogen atom. So these products are formed. This is called substitution product because the aryl replace the halogen atom, and this process is also called coupling reaction because these aryl when attached with these alkyl when attached with aryl group, they form a product of higher alkane. That's why this is also called coupling reaction because in this the one fragment of hydrocarbon and the other fragment of hydrocarbon combine to form a couple. Now I move its mechanism. Its mechanism also contain a radical formation. Here the sodium homolytic splitting takes place on sodium and the radicals are formed. So we take an aryl halide. The homolytic splitting also takes place at this point. So the radical of halide react with the radical of sodium to form sodium halide, and this product is formed. So now we take an alkyl halide and the second sodium radical. So it's also a homolytic splitting take place by this way. Sodium halide are formed and the aryl radical are formed. So when these two radicals are combined to form this product, this product is also called coupling product or substituted product. Now I move its application. It is very useful in laboratory to synthesize the substituted aromatic compound. Now I move towards the third and last one, Fitting reaction. The Fitting reaction was discovered by Wilhelm Rudolf Fittig. According to its definition, in this reaction, aryl halide, the halide, when attached to benzene ring, they form a aryl halide. With combined with metallic sodium in the presence of dry ether to give diphenyl or biphenyl. So it's also a coupling reaction. Now I discuss its example. We take an two aryl halide. These when halide combine or combine sorry when halide attach on benzene ring, they form an aryl halide. When aryl halide react with sodium, they form biphenyl or diphenyl and sodium halide. Bi means two or di means two. That's why we can say it's biphenyl or diphenyl. Now I tell you about its mechanism. By this way, you can easily understand that how this reaction takes place. This reaction is also a form of radical formation. In this, the radical formation also take place. We take an aryl halide, so homolytic splitting take place. The radical of a halide attract to the radical of sodium. They form a sodium halide, and this product is formed. And we take in again aryl halide and the sodium metal radical sodium radical. So the same products are formed. By this way, these two radicals, when combined, they form a biphenyl or diphenyl. Now I move its application. It is very useful for the formation of aromatic biphenyl compounds. With the help of this compound or with the help of this reaction, we can easily form the biphenyl compound. This is the main and major application of this reaction. So I hope you got it all the information about Wurtz reaction, Fitting reaction, and Wurtz Fitting reaction. Thanks. This is from my side.